This press conference today is to release the high-rise study that was conducted by the National Institute of Technology with some partners, and those will be described shortly. People on the phone, we appreciate you tuning in. We will take questions from all of you towards the end. The operator should be giving you instructions on how to ask the questions, so we get them one at a time. But if you stay on, when we get to the Q&A portion, you will be able to ask and get questions answered. My role here is really just to MC. I'm Jeff Zach, and what I want to do is kick this off for everybody who may be contacting people on the phone. You can watch this and you'll be able to rewatch it on www.fireandemsdata.com. That site has all the materials from the high-rise study as well as the video from this press conference. Everybody on the phone can also tune in to watch the press conference through that website. First, I want to bring up Jason Averill, who is with the Fire Research Division of the National Institutes of Standards and Technology. Jason holds a U.S. Department of Commerce Gold Medal Award for the Distinguished Study in Federal Service for conducting the safety investigation of the World Trade Center after the disasters. And he's one of the principal investigators on this high-rise study. Jason?
Thank you, Jeff, and good morning. My name is Jason Averill. I'm with the National Institute of Standards and Technology. I'd first like to set the context for the report that we're going to talk about today. It was funded by the DHS Assistance to Firefighter Grants Program. It is a multi-party effort. The grant holder is the Commission on Fire Accreditation International. And the partners include the International Association of Firefighters, the International Association of Fire Chiefs, NIST, Worcester Polytechnic Institute, as well as the Urban Institute. So with that as background, I'd like to turn the floor over to Dr. Lori Moore-Merrill from the IAFF, who will talk a little bit about what we did.
What I'd like to address this morning with you in this conference is the why the study was conducted and perhaps how it was conducted, to give you a little background. This study is first and foremost about firefighter safety. As we conducted 3 years ago a very similar study in a low-hazard residential structure, looking at the low-hazard response capability of firefighters to address fire in a 2,000 square foot, two-story building, or home residence, if you will. To be able to bookend that, or to then look at the high-hazard environment, was, again, the purpose of this study, so that we could see the difference in firefighter capability and expectation in responding to a low-hazard environment versus a high-hazard environment, and the necessity for increases in crew size as well as deployment capability. So with that being said, one of the other reasons as to why this study was conducted is because we watched as nationally, both throughout the United States and Canada, decision makers were making unilateral decisions in an economic crisis as they were cutting fire department resources with little knowledge of impact of the ramifications of their cuts. And so a lot of this addressed not only station closures, company closures, but crew size reductions. Again, decisions that were being made throughout the country with little idea of what the impact of these decisions would be on both firefighter safety and on public safety. And so that was another reason for the study. Finally, a reason for the study is that we must help to teach our decision makers about matching deployed resources from the fire service to the risk environment into which they're responding. As I mentioned, the low hazard and the high hazard extremes of the risk environments to which firefighters respond, and everything in between. Our decision makers must understand that fire chiefs and the firefighters, as they respond in these environments, they need the necessary resources that they can impact in 3 ways. Firefighter safety, that they can operate safely, efficiently, and effectively. And occupant safety, to reduce injuries and deaths, fire fatalities from the public, and also reduce property loss. And so those are the 3 primary outcomes to the studies that we have conducted. On the high-rise, to give you a little idea of how the study was conducted, we did the study in a 13-story building. The fire was located on the 10th floor. The Subject matter experts from throughout the country helped us to put together the protocols for the study. These experts were brought in to not only develop the study protocols, but all of the deployment that was conducted, all of the firefighter responses that were laid out for the study. The fire, as I said, was on the 10th floor of a 13-story building. There were 2 victims that were involved in the fire. These 2 victims had to be located by each crew that was deployed. 1 victim was on the fire floor, 1 on the floor above the fire. Overall, there were 48 experiments that were conducted with various crew sizes, assessing variables of crew size, looking at 2, 3, 4, and 5-person crews. We looked at also the deployment, how many engines and how many trucks are sent in an alarm. As you are familiar with the first alarm or second alarm type fire, these were to discuss how many engines, how many trucks should be sent in each alarm. And then finally, a vertical ascent mode using stairs or elevators in the high-rise environment, which would be preferred, which is more effective in a firefighter response inside a high-rise. Overall, 48 experiments were conducted using more than 6,000 firefighters throughout the metropolitan Washington, D.C. area to participate in the study. And so these firefighters, again, were helping us to set what will become, we hope, the minimum standard for response to high-rise. What is the floor? What is the absolute minimum number of firefighters on a crew? What is the absolute minimum deployment to a high-rise fire in a high-hazard environment? With that, I would like to turn it back now to Jason Averill to discuss some of the results that were gleaned from this study. So, Jason?
Thank you, Lori. I'd like to talk about 3 of the primary findings that we found upon our analysis. These are summarized in the graphs that you see behind me. The first is about the total amount of energy that was released on the fire ground as a function of the firefighting deployment response. As you can see on the chart, depending on whether they took elevators versus stairs and depending on whether they were 3, 4, 5, or 6-person crews, the total amount of energy that was released on the fire floor was different, and that's based on when they could put water on the fire and suppress it. In summary, the crews that were in the slower configuration faced an environment that had approximately 60% more energy released onto it than the crews who were deployed in a faster environment. The second finding that I'd like to talk about is search and rescue, and that's the middle chart that we have over here. Search and rescue times could vary significantly based both on the number of personnel who were assigned to each crew, 3, 4, 5, or 6, as well as whether they took the stairs and elevators. In fact, you can see nearly a 50% decrease in the time that it takes to complete the search when you look at the 2 extremes, 3-person versus 6-person crew sizes. And that's a significant time, but it's a time. In order to understand what that time means in terms of the likelihood of finding a viable occupant, we needed to conduct computer fire modeling. Using the NIST fire dynamic simulator, we were able to calculate what the toxic environment was like on the floor for anybody who required rescue by the fire department on that floor. The third graph that you see there is our summary of the toxic exposure for theoretical occupants on that fire floor. And what we can see is we looked at the 3-person, 4-person, 5-person, and 6-person crew configurations is a very significant difference in the fractional effective dose. A fractional effective dose is a scientific term for the effect that combustion products have on an occupant who's exposed to that amount of dose. And in the graph there, you see that the blue represents the lowest amount of exposure. The yellow is slightly higher. And at the top of the yellow bar, that represents the point at which 50% of the occupant, your median person, would become incapacitated by an exposure to that type of fire dose. And then we also have higher than 50%, more likely than not, that the person would be incapacitated, represented by the orange. And in summary, you can see that for the 6-person crews using the stairs, all of our rescues at the time at which the fire department crews were able to get to an occupant located in that position were in that blue fractional effective dose, indicating a fairly high likelihood of a viable rescue. And as you move through the different configurations, looking at the 3-person crews using the stairs, we see many more in the yellow and orange category, which is a decreased likelihood that the person who is being responded to by that deployment configuration would be successfully rescued. With that, I will turn it back to Jeff Zach here.
Thank you, Jason. To talk about the practical effects of the results, how the results of this study and the need for larger crew sizes to respond to save lives and property early, we have with us today Chief Dennis Compton, who's a retired fire chief from Mesa, Arizona. He also sits on the board of directors for the International Fire Service Training Association and currently sits as the chair of the National Fallen Firefighter Memorial. Denny?
Good morning. It is really an honor to be here today. I'll tell you that to see the outcome of this work and over the years that we've been trying to complete this project is absolutely amazing. This is my 43rd year in the fire service, and I can tell you I've dealt with high-rise fires as a firefighter, actually trying to extinguish them, as a company officer, attempting to direct those operations inside those buildings, as a battalion chief and a deputy chief, as a commander of working high-rise fires, and as a fire chief, trying to figure out how in the world to get the resources to not only be effective on those fires, but to keep those firefighters safe as we go about it. And one of the things, and probably the most important thing about this study, is that it is going to assist fire chiefs, union officials, and just as importantly, city managers, county managers, district managers, elected officials, in making informed decisions about the resources that we send to those events. And think of it kind of as a decision tree if you're a firefighter. You know, we don't think about those very often, but that's what it is. Is that first of all, a community has decided that they're going to allow high-rise buildings in their community. Either they already have or they're going to. That's the first step. And then secondly, if you are going to, those are such high hazard fires that we need to do everything we can to prevent them. Is we simply cannot allow those fires to occur. They're high hazard for the public, they're high hazard for the firefighters. However, time and time again, either in unsprinklered high-rise fires or in sprinklered high-rise buildings, we continue to find ourselves in situations where we have to encounter those fires physically. Okay? So the next step in that decision tree is that if we're going to allow them to be built, we're going to do everything to prevent them, we have to have a fire department that is appropriately staffed, trained, equipped, and deployed to deal with them effectively. And that is perhaps more than anything else what this study brings to us as fire chiefs and other decision makers in the fire service. It is a roadmap for us, a roadmap to help us not only make decisions ourselves, but to help our leaders, our community leaders, make better decisions about protecting those communities. So I couldn't be more proud to have been involved in this study. And I'm really encouraged not only for what this study can provide for us as a fire service, but for us as a nation in the way of safety. Thank you very much.
Thank you, Chief. Next, we have a guest who is going to talk about how the results of this study will help those who set national standards. And for workers all across the country, we have bodies that set standards in different industries. In the United States, for fire, it's the National Fire Protection Association. And they set standards that are recommended as national standards. And up here to discuss how these results will affect that process is Chief Russ Sanders. He's a retired chief from Louisville, Kentucky. He serves as the executive director of the Metro Chiefs and the Central Regional Director with the National Fire Protection Association, which is the industry standard setting organization. And he's the author of firefighter textbooks on high-rise firefighting. Chief?
Thank you very much. I want to echo what Denny said. It's certainly been an honor, a pleasure and an honor being involved in this study and the previous studies. For the last 6 years, we've been working with NIST and the IFF and all the other partners that have made this possible, and I can't tell you how impressed I've been with the quality of work. But as Jeff said, I'm going to speak from the perspective of a consensus-making organization that develops professional standards for our profession, the fire service. Specifically, I'd like to talk about NFPA 1710. For those of you that don't know, that's a staffing and deployment standard published by the National Fire Protection Association, NFPA. And we just happen to have the chair of 1710 with us today, Chief Bryson. And as Chief Bryson certainly knows, he and his technical committee members have been limited to anecdotal information in the past. Good, solid information, information built on trial and error over decades and handed down, but unfortunately, it doesn't have scientific credibility. And unfortunately, in many cases, that learning experience came at the cost of both civilian and firefighter lives. So I can't overemphasize how important it is to have this scientific information now available to the NFPA 1710 committee, that I know Chief Bryson and his committee members will closely review and look at and consider and implement these lessons learned into that standard. That's so important. And knowing that reassures policy makers, elected officials, all the decision makers, the firefighters, that our professional standards are built on solid scientific information. Thank you very much.
Okay, what we want to do now is be able to take questions, and we have a number of people on the phones, and we're going to find out in a second here. Operator, if anybody on the line has questions, we'll take them first, and so just chime in when somebody on the line does have a question, and I'll relay it. But for the effects of this study, for everyone who's on the line and who's watching, we sent out the press release. The press release documents the information that tells you why this is important. And this is important because high-rises are in just about every community, every larger, medium to large population center these days. A high-rise is a building of 10 stories or more, 7 stories or more technically. And this study was conducted on the 10th floor of a 13-floor building. 42% of all high-rises do not have sprinklers. So the need for appropriate response is something that is spread across every community in the country, and that's what these results help quantify. Operator, is there anybody on the phone who has a question?
If you would like to ask a question, please press *1 and record your name when prompted.
While we're waiting on that, any of the reporters here in particular have questions that they would like to address? The question is, what are some of the building materials and the toxic substances that burn, that create the hazard in a fire?
Sure. The estimate of toxic exposure was computer modeled. The data that went into the computer model was taken from laboratory experiments that were done a number of years ago on basically cubicle construction. So you're looking at typical foams and plastics and wood construction. And those parameters from the experiments that were done for another purpose were pulled out, put into the computer fire model, and then that was what was used to estimate the toxic exposure.
Others, okay. Operator, is anybody on the phone?
I'm showing no questions at this time.
Okay. What I want to point out for the local media in particular, question here?
Yeah, how does this, he mentioned an office building. How does this apply to a residential high-rise?
The experiments were conducted, as you noted, in a commercial high-rise. There are some of the data that will absolutely translate into the residential environment. On the fire floor, it was an open floor plan, so the fire was able to spread quite quickly, very rapidly across this open floor plan. On the floor above the fire, however, we did have some more offices with the closed doors, that sort of thing, and so we will be able to translate much of the results into the residential environment as well. The high-rise response is pretty much the same. Every square foot of the building has to be searched, everything above the fire, and so the response would play out equally well from commercial into residential.
Hearing and seeing no further questions. If anybody on the phone has a question, you can email it to highrisestudy@iaaff.org. We also have a number of chiefs here from jurisdictions across the United States and even a couple from Canada who are available to answer questions if a local jurisdiction has some questions, particularly for a chief. Otherwise, for the local cameras that are here and the other reporters, we have some responders from Phoenix who are here along the wall who have brought their apparatus, have brought their equipment to show you when they're going upstairs. They're not just jogging up in running shorts and running shoes. They have all this on their backs. They're here to talk about how it applies here, particularly in Phoenix, how the results can affect the way they respond in the future and how they do it now to protect the community of Phoenix. So with that, I'll take some questions from the chiefs here if they have any. Otherwise, we'll wrap it up and move outdoors so these guys can show their wares outdoors and speak specifically to the Phoenix angle. Okay, thank you all very much for tuning in and for coming today, and we'll see you in the future. Thank you.